Everybody. Welcome to this month's webinar series of the Material Science Pioneers in Art and Archaeology. This is a webinar series that's being hosted by the Art, Archaeology, and Conservation Science Division of the American Ceramics Society. And my name is Celia Chari. I am the host for today's talk. And I'm very excited to introduce our speaker for the month, Dr. Rosarosa Manca. Before I start talking about her and the introduction, I have a couple of updates from the division, just to do some housekeeping. So the first is that in addition to this webinar, the AACS division is also hosting a symposium at MS&T in Pittsburgh, Pennsylvania, October 4th to 7th of this year. And we are no longer accepting abstracts for the symposium, but you can still register to attend and make sure to register before August 28th if you want the cheapest rates. And I'll add the information in the chat. The other conference coming up is the Gordon Research Seminar and Conference on Scientific Methods and Cultural Heritage that's going to take place this summer in Les Diablerets in Switzerland from June 11th to the 17th. And applications are currently open. They must be submitted by June 13th for the GRS. So this is the seminar that is targeted more towards graduate students and postdocs. And applications are due June 14th for the conference itself. So this is the one open to all in heritage science. So there is still time to apply, and I'll also put the links for those. I've been getting a few emails asking about whether these webinars are going to be recorded, and they are. Their past webinars are actually uploaded in the ACerS YouTube page. So if you missed talks in the past or cannot make it to talks in the future, rest assured that the majority are recorded and you can find them online. I think currently we have 4 or 5 talks there. So from every month this year, there's been a speaker. And I'll include the link in the chat. Lastly, if you're interested in becoming a member of the American Ceramics Society, I wanted to draw your attention to different types of memberships that are available. I've mentioned in previous webinars that we have the ability to sponsor graduate and doctoral students. So if you're pursuing a master's or a PhD and you're interested in AACS and the American Ceramics Society, please email myself or Vicki Evans, filling out a form, and all that information will be in the chat so that your membership can be sponsored for 1 year. Yes, for free. Otherwise, if you are interested in joining and you are new to the American Ceramics Society, so if you are in conservation or cultural heritage and you've never been a member of ACerS in the past, you can actually get 1 year complimentary as a member through the associate membership program. So this is just a form that you submit and you apply to, and you can get that 1 year for free to test it out and see how you can benefit from the society. So I'll put all of that information down, and that way you can access it. Okay, so I think we're ready to introduce our speaker. Dr. Manca holds a PhD in Earth Sciences from the University of Florence in Italy, where she investigated the impact of 19th century chemical and industrial innovations on the production of revival gold jewelry in Maiolica in Italy. Dr. Manca is currently a heritage scientist at the University of Florence, where she more recently has investigated the past use of mercury-based conservation treatments in natural history museum collections. Today, she will be talking about her work on non-invasive scientific analyses of 19th century tin glazes in Maiolica ceramics. Please welcome Dr. Manca.
Thank you very much for the presentation and for the invitation to present here today. It's a great honor for me. So I will share my screen and presentation. You should be able to see it now. Okay, so yes, as I said in the presentation, today we will talk about Maiolica, made in the 19th century in Italy, and what non-invasive scientific analysis can tell us about them. This is a a brief outline. Sorry, I can't see the whole screen, but I think it's fine. A brief outline of my presentation. I will start with an introduction about what Maiolica is and why the 19th century production is so interesting, according to me, and I hope you will agree. And then I will present 3 case studies. The first part, which will be the main part of my presentation, is a study conducted in the framework of my PhD project in collaboration with the Victoria and Albert Museum, studying that collection by ACerS spectroscopy. The second case study explores the application of ion beam analysis to the study of Maiolica, something on which I've been working in the last few years in the framework of master's and PhD thesis that I co-supervised in collaboration with the National Institute of Nuclear Physics in Italy. And lastly, I will briefly touch on the application of another non-invasive analytical technique, which is hyperspectral imaging, and I will present you a study that we conducted in collaboration with the University of Bordeaux-Montaigne at the Bargello Museum in Florence. So to start, what is Maiolica? Maiolica is an Italian word used to define tin-glazed earthenware. It is normally used in Italy with this broad meaning. It wasn't always like that, but more recently this is the meaning. And in English is normally used to refer to the Italian production, of course. The etymology is quite uncertain, but it possibly comes from the name of the island of Mallorca, which was an important trading port from where the Hispano-Moresque productions were imported from Spain to Italy. And indeed, the tin glazing technology comes from the Eastern world, from the Islamic world, where it was first developed in the 8th century, probably to imitate the beautiful Chinese porcelain. And it arrived in Italy only in the 13th century through the mediation of Islamic Spain. From a material point of view, what characterizes Maiolica, and I'm sure you will know, is the presence of a white ground glaze applied on the first fire biscuit. This white ground is obtained by adding to the glaze an opacifier, which is tin oxide. And on top of this white ground, you can apply color decorations and then fire again your artifact, and you obtain a stratigraphy layer structure, which is more or less like this one. The composition of Italian Maiolica glazes is rather well known, both from historical documents and sources, but also one for all is the very famous treatise by Cipriano Piccolpasso, written around 1557, which is entirely dedicated to Italian Maiolica technique, but also, of course, to previous archaeometric analysis, which were conducted mainly by SEM, EDX, so electron microscopy, which I would say is the golden technique to study this type of artifacts, and it was the most common. So what it is basically either a high lead or a lead alkali glaze with these materials used as opacifiers, and of course lime and alumina as a stabilizer and tin oxide as an opacifier, which is the key ingredient, I would say. As for the colorants, these are the main materials used, very common colorants in glazes: copper green, manganese brown, cobalt blue. Yellow was obtained with lead antimonate, either pure or modified with tin and zinc. And with the addition of iron scale, you could obtain an orange hue. The red color was rather not not very much used because it was very unstable, but was obtained with iron oxides. And then the black, which is basically a very dark blue or a dark brown, and the white made with a tin oxide. And then we have the lusters, which are these metallic iridescent decoration obtained with metallic copper and silver particles, which were fired in a third firing. So with this palette, Italian artisans obtained, and artists, I would say, obtained this type of manufactures. It is during the Renaissance that tin-glazed pottery in Italy reached a moment of extraordinary sophistication, I would say. And painted Maiolica was really a branch of Renaissance painting, and became in that period a luxury good, even though the materials used, the raw materials used, were not so expensive compared, for example, with metalware. So skipping a lot of centuries, what happened after the Renaissance is that Maiolica went slowly out of fashion. Other type of ceramics were preferred, and Maiolica was produced along the centuries, but mainly for very simple wares, tableware, mainly for domestic use. But artistic Maiolica was not produced anymore. It is only in the 19th century that there is a revival of the interest in Maiolica, and there are specific reasons for it. So the 19th century is a very interesting century of cultural and technological transformations and changes. One very important feature is that the century was characterized by a great fascination for past civilizations and also the artifacts they produced. It is the century of great archaeological discoveries, and in which archaeology itself was born as a discipline. And also very important is the century in which national identities start to arise in Europe. And specifically in Italy, we have the unification of Italy with the Risorgimento, and these cultural atmosphere strongly influenced as well the production, the artistic production. As regards Maiolica, this became one of the type of production to which the intellectuals and artists, but also the collectors were looking at with great curiosity. And so Maiolica started to be studied again, but also traded and copied, and of course, since the market was very vivid, also forged. Another interesting feature is that we witness in this period to the development of the revival or historicist style. So, for example, the Neo-Renaissance or Neo-Gothic style, which is very peculiar of this period. And last but not least, the 19th century is the century of chemistry. New pigments and chemicals became available this period thanks to the Industrial Revolution, which took place, which started many years before, but it is in this period in the 19th century that chemicals really became available for use on the market. So regarding glassy material, let's say, so glazes, glass, and enamels, here is a list of the most famous new materials introduced during the 19th century. As you can see, they are mainly colorants. For example, chromium oxide, uranium oxide are very famous, but also the cadmium yellow, which started to be introduced in the productions. But we have some information about them. For example, in the introduction in the enamels or in glasses, but we don't have specific information about tin glazes. For sure not in Italy. So my question was, were these materials really used in Italian Maiolica? Where they were available, but were they really used? And if so, by which manufacturers and in which period? So can we find more or less a date from which some of these materials were introduced or not? And this was interesting to me, of course, because I am, and I guess you are, interested in the history of technology. So this was something really interesting to me. But it is also important in the field of authenticity studies. And indeed, as I mentioned before, in this period, a great amount of forgeries were produced and were sold and collected, and now they are in private collections and also public collection, where they ended up through various acquisition routes. So it is very important for a correct interpretation of these items to know whether they are original or 19th century forgeries. So with these questions in mind, I started this part of my PhD project in collaboration with the Victoria and Albert Museum in London, which has a very beautiful collection of 19th century Italian Maiolica. This is the collection and the objects that we analyzed, which are almost all the whole collection was analyzed. And as you can see, these are items produced between the 1855 and the 1900 by three manufacturers, which were the most important manufacturers of the time. So the first one is the Ginori Manufactory. This was the biggest ceramic producer in Italy at the time. It is most famous for the porcelain production, of course, because it is one of the first porcelain factories in Europe. And but it was producing Maiolica since the beginning. What happened in 1848 is that the director of the time, the Marquess Lorenzo Ginori-Lisci, decided to establish a new production exactly of artistic Maiolica. And he was the first one to start this type of revival production. He has different reasons to do it. First, as I was saying, a patriotic reason. He was really involved in the politics of the time and in the Risorgimento process. So he identified Maiolica and artistic Maiolica of the Renaissance as one of the great success of Italy in the past to be revived. The other reason was that these objects had a very good market at the time. There was a great demand for them. So, of course, there was also an economic reason to produce and sell them. And indeed, it had a great success. In 1855, he presented for the first time at the Universal Exposition in Paris, and he was even awarded for the rediscovery of the luster technique that I was mentioning before, and it was lost along the centuries, and he was awarded for its rediscovery together with his chemistry lab. Another interesting thing is that this first production was originally requested by an art dealer, actually, whose name was Freppa. So the first object specifically, I don't know if you can see my pointer, is this with the portrait of Barbarossa, which is really one of the first objects produced by Ginori of artistic Maiolica. And it was produced for Freppa, who unfortunately was discovered selling the Ginori pieces as original Renaissance ones. So there was a big scandal, and the Ginori manufacturer was involved at the beginning, but then managed to deal with it. But I wanted to mention it because, of course, this border between forgeries and revival production is always a bit tricky. The second ceramist that I will talk about is Torquato Castellani. He had a small workshop, but not a manufactory, in Rome, and he was the promoter of the revival of Maiolica in Rome, which occurred after the unification of Italy in 1861. And he's a member of a very famous family, the one of the Castellani, which were goldsmiths, the most important goldsmith of 19th century Europe, I would say, or among them, and also the son of an important antique dealer, who is Alessandro Castellani. And finally, the Cantagalli manufactory. It was established a bit later in 1878, again in Florence, in Italy, and founded by Ulisse Cantagalli, who was really a visionary, and he had this idea to revive the craftsmanship and atmosphere of Renaissance Florence, but at the same time to promote the industrial relaunch of the city. So he also had an important production and was the most important competitor of the Genoa manufactory at the end of the century. So the V&A collection of the great opportunity not only to analyze this object, that I forgot to say have the very important feature to be dated, which is of course very important and to interpret our data. But not only 19th century object, I was saying, but also the Renaissance models that inspired them. So in these two cases, we could analyze the two dishes, the two plates that you can see on the right, which are the direct models which inspired, in one case, Torquato Castellani, and in the other, Ulisse Cantagalli. And we could compare directly the two compositions. And finally, this beautiful plate made in Urbino in 1545, which has some 19th century additions that, according to the curator of the museum, Rino Litkes, were possibly done by Ginori. So these are the objects that we analyzed, but the question was how to analyze them, how to get information about their composition. Of course, they are museum objects. They are very well preserved. They are in perfect condition, so we could not sample them. And we had to rely on non-invasive in situ analysis in the museum. So that's why we chose to use X-rays fluorescence spectroscopy, which is a very common technique, I'm sure you know very well, based on the emission of characteristic X-rays, which allows us to define the elements present in the materials we are analyzing. It has the great advantage of being completely non-invasive, but of course we have to keep in mind also the limitation of it. So being an elemental analysis, we cannot obtain information about the glaze microstructure and on the crystalline components which are present, which of course we can do with SEM, for example. Also, we don't have information on the layers and on the single layers that we are analyzing. We obtain a general composition, which is probably a mixture of different layers. And the quantitative analysis is problematic. In our case, well, for the nature of the material, which are very dishomogeneous, but also because we didn't have appropriate standards, which are quite complicated to do. So we decided just to rely on qualitative analysis in this case. And last, glazes are complex materials with a lot of elements, so one has to be really careful with the interpretation of the peaks because there are many interferences. So it's very easy to identify the wrong element by mistake. So one has always to keep that in mind. And this is the the spectrometer that we used at DNA. So going to the results, what we could see analyzing all the objects I show you, basically the composition of the glaze that of the glazes that we analyzed was a traditional one of Italian Maiolica, corresponding rather well to that I described before. So high lead glaze with tin, and the colorants as well are just the traditional ones. Including those for the last step, at least as far as we could see with the ACerS. So that's interesting because it tells us that they were not imitating only the style of these objects, but also the materials and techniques to make them. And this was possibly due to a continuity of the technique during the centuries and the decades, but possibly also to a experimentation by these manufacturers. But there is an exception to that I just said, which is the presence of zinc in the white glazes. So the zinc oxide was one of the materials introduced in the 19th century that I showed you a few slides before. Its presence is important because it was refined and commonly used only from the 19th century in vitreous materials. It was present, it can be present also in earlier artifacts, but it's normally present in colors. So it was very common, for example, in yellow glazes, also in blue glazes. It was added in with as materials known as alexandrine, tatti, or similar names, but it was not used in the white glazes, in the white browns. So we could identify these elements almost in all the objects, but not in all of them. And these indicate that they were intentionally using it to improve the optical and mechanical property of the glaze. And what is interesting to me is that they most probably knew that it was not a material of the tradition of the Renaissance. At that point, especially in later periods, the traditional composition was rather well understood, but they choose to experiment to the newly developed materials of the industry. So, and the other only element that we can define modern that I detected is chromium. I found it in blue and green areas of only 4 objects by Cantagalli and by Torquato Castellani. So it means that it was indeed used, but it was not very common. And again, this is a very famous pigment introduced in the 19th century, but apparently was not very popular among ceramists or Maiolica producers. What was very interesting is that we never detected the chromium in the Ginori artifacts. And this is interesting because we know that chromium oxide was used, chrome green was used at the manufactory at least since 1810, and for sure for porcelain, and they were buying it from Paris. We found a few indications of it in the archives of the manufactory. So they had this material available, but they decided not to use it for artistic Maiolica. And going to the comparison between the original 16th century artifacts and the 19th century reproduction, we could see here in this plate that basically the composition is very, very similar. The only difference is in the presence of zinc in the white ground of the 19th century and of small amount of chromium in the green areas. This is the other example. This is really a masterpiece of Italian Renaissance. Was made by Mastro Giorgio in Gubbio, and as you can see, this was very famous for his luster. application, and I hope you can see in this video in which simply moving the plate and so the light changes and makes this amazing effect. So this is really really beautiful. And you can see the reproduction that Torquato Castellani made of him in 1870. You can see that the composition is a bit different, and the main difference are indeed in the luster decorations. And you can see here that what was a yellow luster in Mastro Giorgio painting became yellow in Torquato Castellani ones, and indeed it is an antimony yellow, while we have this other yellow decoration on top of the blue, which acquired this sort of, I define it, lilac color in Castellani's one, and finally this beautiful ruby red in the original one, which is a very dark red, almost brownish color in Torquato Castellani's. So what did the analysis tell us? The composition of this dark red was very peculiar. We found gold, traces of bismuth and cobalt, and in the lilac ones, even traces of uranium. So it's very hard only from the XRF analysis to say which role had these elements in this glaze. We can make some hypotheses. For example, gold nanoparticles are used to color glasses in red. There is purple of Cassius, even the Böttger luster. So maybe you have some indication about it, but we are not really sure. We see also tin in the glaze, but of course it is a thin glaze, so we are not sure that this is due to the presence of purple of Cassius, for example. And also the presence of bismuth is a bit uncertain. I found references to the use of new iridescent bismuth lusters, but more really at the end of the century. We are in 1870, so maybe it's a bit early, but bismuth was used as a flax and to make the, for example, the gilding adhere to porcelain glazes. So I don't know if this was the role. And again, with uranium, could be an impurity correlated with bismuth, or could it be like a yellow uranium oxide added to a mixture of colors, which for sure included cobalt, which is either present underneath this color or in admixture to it. So I don't know exactly. It would be very interesting to do further analysis, but for sure it tells this peculiar composition tell us that Torquato Castellani was experimenting in new materials. And finally, this is the dish with the integrations. We could see that the fragment number 2 is just an original fragment, which probably detached from the main dish and was reattached, while fragment 1 and 3 have a very different composition, which basically has no potassium and very low calcium. And this composition is very different also to all the others that we could see by Ginori. So this makes quite unlikely that it was the Ginori manufactory to make this restoration, although we cannot completely exclude it, of course. So to summarize this first part, the analysis of the glazes of these 3 important Italian ceramic producers of the 19th century revealed what is to me a very fascinating balance between tradition and innovation, which is very typical of this period. And it was described very well, I think, by Fuchs in an essay where he described the historicist ceramists, saying that they tried on one side to recover ancient knowledge, and on the other, with the means of chemistry and industry, to surpass it both in the appearance of the product compared to the ancient ones, and in the cost or production in production scale. So I think this is a very synthetic and clear reconstruction and description. Regarding the methodology, XRF analysis, of course, it's not perfect, but allowed us to acquire precious information on 19th century production practices. 19th century objects have been really overlooked in archaeometric studies, in my opinion. So even if it's not so much, at least it's some information which can start to build knowledge on this period. But what is important is that it may be not sufficient for a complete authenticity assessment, since apparently the colorants and the main components of the glazes were very similar or were just the same as the ones used during the Renaissance. So going back to the slide I was showing before with the new materials of the 19th century, there is only one element among them that we cannot detect by XRF, which is boron, which is the main component of borax. So I was left with a doubt that maybe borax was present, but I couldn't see it by XRF. And why boron is important? It is also a material which started to be used more frequently in the 19th century, and I will tell you why in a moment. It is a flux. It was very commonly used in jewelry historically. It was a very expensive material, so that's why it was used in very expensive productions. But in glazes, it's important also because it reduces the thermal expansion coefficient, so makes it easier for the glaze to adhere to the surface, and it also increases its brilliance and its mechanical strength, and it is an anti-graze. So my question was then both Tuscan Maiolica? And these interest in Tuscany raised because at the end of the 18th century, Francesco Hofer, a chemist, discovered the presence of boric acid in Tuscany. And in the 1818, they started to exploit this boric acid in the city now known as Larderello. And this was the first source of boron exploited in the Western world, while for centuries, or if not millennia, it was imported from the east, from Tibet, maybe. So it was very interesting to me that this occurred exactly in Tuscany, very close to the Ginori manufactory, and we even have a documentary, a document testifying that a connection with Ginori, because Francesco Hofer, when discovered boric acid and transformed it into borax, sent a few samples first to jewelers to experiment with it, and secondly to the Marquis Ginori, the father of the one I was talking before, asking him if it was good to use it in glazes. So I was thinking, possibly from this period, since borax was more common, they possibly started to use it also in Maiolica glazes. And what I forgot to say is that borax started to be very common from the 19th century because the discovery of sources in Europe and later on in the States and in Chile make it much cheaper, basically. So, but how to detect boron in the glazes? XRF and SEM cannot detect it, so I had to rely on another type of technique, which is ion beam analysis, and specifically particle-induced X-ray emission and particle-induced gamma-ray emissions. These are two techniques which rely on the use of particle accelerators, which produce a beam of protons of specific energy between normally 1 and 3 MeV, and the interaction of this proton beam with the target atoms causes the emission of characteristic X-rays and gamma rays. And it is thanks to the emission of this and detection of these gamma rays that we can detect boron and other light elements, because gamma rays have a very high energy, so we can detect them. This is the laboratory that we used. It is the Laboratory of Nuclear Techniques for the Environment and Cultural Heritage in Florence of the National Institute of Nuclear Physics. And it is one of the few laboratories of this type dedicated to cultural heritage in Europe. So we were very lucky to use it. Of course, it is not it's a disadvantage to require such a big facility and a rare facility, but the use of such a complex equipment is due to the many advantages that it brings. First of all, the detection of of elements with low atomic number, as I was saying, but also that the techniques are very sensitive. Can analyze and detect also elements present in trace amounts, and we can perform quantitative analysis. And unfortunately, we could not bring the object from the V&A in Florence, so we had to find other objects, this time from private collections. And these are the objects that we initially analyzed, that are made in Tuscany between the 18th and the 20th centuries. And they are again objects by Ginori, but earlier ones. So more or less from the beginning of the 19th century. The dating is not so precise, unfortunately. And then we also analyzed another production, which is the one by Galileo Chini. Chini is a very important artist in Italy, one of the major representative of the Art Nouveau in Italy, and he founded two manufactories mainly. First the Arte della Ceramica from 1898 to 1904, and then the Fornaci San Lorenzo from the 1910s to the 30s. And finally, the Pecchioli-Chini, which is much more recent, and we had one object of the 1960s. And the different dating of this object was very useful and certain because of these different manufacturers owned by Chini. And then a few objects by the Società Ceramica di Colonnata, again Cantagalli, and the Maiolica manufactory. And indeed, we detected boron in 8 objects. Sorry, there is a mistake. Here you can see an example of a PG spectrum with the peak of boron. And these are the objects where we detected it. It is interesting that we did not detect boron in the earlier objects. So the one closer to the discovery of the boric acid in Larderello. But the first object where we detected it is this little vase by Ginori, which is very precious. It is decorated with this beautiful purple color. And very importantly, boron was not detected in the glaze, but in the purple color. Which is the famous purple of Cassius with the detected gold and tin. It was a very precious pigment used mainly on porcelain, but this is a rare example also on Maiolica. And one characteristic of this color is that it has to be fired at low temperature, so it needs a flux. And indeed, in the archives of the museum of the Ginori manufactory, we found that the flux to make the purple is made with lead, crystal, and borax. So in this case, borax was just used for the pigment and not in the white glaze. The other objects where we found boron, we found it in the white ground this time, and are all already of the 20th century. In the first object by Arte della Ceramica by Chini, we never found it. So this led us to think that possibly boron started to be used later on in these, at least in these manufactories that we analyzed. So to conclude, PIG analysis proved to be very precious for the quantitative non-invasive characterization of the glazes, identifying also low atomic number elements such as boron. But these preliminary results suggest that borax became common in tin glazes only in the 20th century and not before. So the exploitation of boric acid in Tuscany does not seem to have a direct influence on the introduction of this material. But of course, the number of objects that we analyzed is not so high. And also the data are a bit uncertain. So the work is in progress. And currently we are also analyzing some porcelain artifacts of the same period to compare them. So very briefly, my last case study, which I will just mention, also because it is already published, so you can see more of it in the publication. It is a study that we conducted at the University of Florence in collaboration with the University of Bordeaux, Montaigne, and the University of Pisa, and specifically with the colleague Francesca Galluzzi, who was the one in charge of the analysis of the spectra. So for all the technical, the more technical question, I hope that I can answer. So hyperspectral imaging, we were using this ultra portable camera of the University of Bordeaux that you can see here inside the Museo del Bargello during the analysis. And it is a very interesting technique, mainly used for paintings, in which we can obtain, by which we can obtain an image of the object analyzed, but for each pixel we also have a reflectance spectrum. So these are the characteristics of the camera, and the main challenges that we were facing were that these objects are really highly reflective, of course, being glazed, and comparing them with paintings, which are the main material to which this technique is normally applied. They are also three-dimensional objects, so the data analysis and acquisition is a bit more complex. Also working in the museum, we had limited lighting conditions, so we and a limited reference library specifically on glazes. So what we did was just to try to make this analysis and see if the technique was good to tell us something about these objects. And which objects? We were at the Bargello Museum. It is one in Florence again. It was founded in 1865, so it is one of the important museum of decorative arts born in the 19th century, and it has a very beautiful collection of medieval and Renaissance Maiolica. So if you have the opportunity, just go and have a look, because it was also recently refurbished. We had been contacted by the curator of the museum a few years before, because he was we wanted to know whether some of the objects of the museum were indeed 19th century forgery. He was really uncertain about it. So we analyzed a few objects and dated them also by thermoluminescence. So we had a few objects that we had characterized and that we used to test the hyperspectral imaging technique. And also a few objects that were unknown, and we will try to learn more. So with hyperspectral imaging, we were able to identify all the colorants present in the glazes analyzed, and the results were completely in agreement with the ACerS and SEM that we performed earlier. Indeed, for some colors, such as cobalt blue, hyperspectral imaging was even more successful because this colorant is present in very low amounts. So not always by ACerS we can see it, while with hyperspectral imaging we could always detect it. But of course, one of the most powerful features of the technique is the imaging, so that we can visualize all the components. And in this case, we could easily identify a fragment, a restoration in this object, and clearly differentiate the two compositions, which again, as we saw already in the other case study, were very similar. Maybe not diagnostics, except for the presence of chromium in the cobalt blue of the restoration fragment. In this case, was also very interesting because we were able to map the different colorants despite the very three-dimensional irregular shape. And we could see that this is a pastiche made of 5 fragments together, which could be attributed to 2 different groups. But unfortunately, in this case, we were not able to see which one were the original fragments and which one were the later additions. In this case, by ACerS, we could detect again zinc in the modern ones, but we could not see any difference by hyperspectral imaging, of course. This last example, these are 2 objects which were forgeries, and indeed with the ACerS, we could see in one of them, the one on top, the presence of chromium in the blue, which suggested that it was a bit a strange composition, at least, that suggested there could be a forgery, and this was confirmed by thermoluminescence. And the same composition was detected in these little leopard figurine, which probably is also a forgery. So just to conclude, since we struggled a bit with the identification of some spectra, we wanted to have a reference data set specifically for Maiolica glazes. So we recently published a collection of hyperspectral imaging data collected from a high number of Italian Maiolica fragments, which are also available as another repository for free access and release to other scholars. So with this, I conclude. I hope that you all agree with me that 19th century productions are very interesting, and they definitely deserve more studies. The use of non-invasive analysis, I think it's very important. Sometimes it's the only option we have. We have, of course, to be very careful in the type of information that we acquire. Probably we need more detailed information to differentiate the 19th century production from, let's say, 16th century or 14th century ones, because they are indeed very similar. But I hope that this first part of studies will be a good start for future applications. And I would like to acknowledge all the people who helped me in these works at the University of Florence, National Institute of Physics, and all the other that you can see here, and of course the museums and the private collectors which allowed the analysis and facilitated them. Thank you very much for the attention.
Thank you so much, Rosarosa. That was an amazing talk. I'm also just really excited to see this finding of boron in purple of Cassius and yes, other glazes that contain gold. It makes me want to revisit some of the Meissen pieces that I've looked at that have purple of Cassius and Butger luster to see whether it has boron too.
Yeah,
Yeah, it's so
definitely.
difficult
We
to.
are always seeing it also on porcelain. We are analyzing purple of classes on porcelain, and we are almost always seeing the presence of boron.
That's really interesting. And then the ties
Mm,
back to the borax mining. That's really, really fascinating. So
thank
we
you.
are open to questions. If you have any questions for Dr. Manca, please put it in the chat. I can start us off just asking a little bit about these non-invasive technologies and being able to pick out these pieces of information that give you clues, but because you're not able to look at this microstructurally, um,
Mm,
have you been carrying out experiments to better understand the reaction mechanisms that could take place or the reasons behind adding, for example, I think for one of the glazes you found, for the gold glaze, the dark gold, no, the dark red
mm.
glaze that had gold, you found traces of bismuth, uranium, cobalt. To piece together why you're finding this, do you carry out experiments also, or is that something that would be like a dream to do in the
Yeah,
near future?
yeah. Well, for sure, making experiments would be key and very important. Unfortunately, I haven't to date. Um, but the main support, let's say, to my interpretation to date has been the document, the archives, and also the manuals, because in the 19th century they were writing quite a lot of manuals. So we had some. We are lucky because they are quite recent objects, so we have quite a literary production at the time. And in many times we could find indication about them, about the use of specific materials and how to make them, and why using some ingredients, let's say. But of course, this is not always possible, and maybe I don't know. The recipes are from a French scholar, so we are not sure whether in Italy as well they were using this technique. So for sure, it's not complete. Uh, in the case of the Ginori manufactory, there is a very important archive as well with a lot of recipes, which is really, really important. But unfortunately, in the other cases, we don't have it. Like for example, for Torquato Castellani, there is no information available, so this remains a bit of a mystery.
Yeah, okay, that makes sense. But it's nice to know that at least some of the records exist. Uh, so we have a question from the audience from Nicholas and Bulyatis. For light elements like boron, how would you compare the usefulness of this ion beam analysis to LAICPMS?
So of course I did not perform this type of analysis just because it's distracting. But I know a study by, if I'm not wrong, Beauvoir, performed on samples of a 19th century manufactory in France. And they indeed compare the results obtained by ion beam analysis and laser ablation mass spectroscopy, and the results was quite similar. And if I'm not wrong, I need to double check, but they saw that with ion beam analysis, the analysis of the standard was actually more accurate than with mass spectrometry.
Hmm, great. Okay, so we have a couple of questions from the audience. The first is from Manus. I can only imagine how nerve-wracking it must have been to handle and analyze these artifacts. I had two questions. My first one is regarding the durability, or rather the effect of time on the glazes. Do you believe that age can have an effect on the elements detected? My second question is related to a broader historical aspect of glazes and colorants. To your knowledge, are there examples of similar artistic techniques seen in other regions of the world?
Hmm. So I had this slide ready, but then I didn't have time to read it. So this is a perfect opportunity. The tin glazes are really well preserved. We don't have much degradation, especially in these objects which are quite recent and were never buried, I think. So there is a very beautiful description about from Timothy Wilson, saying that the colors of Maiolica have remained vivid and unchanged since the vase left the manufacturing workshop, and this is what makes it very special. So I thought this is a very a beautiful description. So regarding the conservation, and this is not an issue in this case, I would say. For the other question about the pigments, of course, yes, tin glazing is not an Italian technique originally, even though it really developed a lot in Italy as well. But there are many examples from South Africa, from Spain, from the Eastern world, absolutely. So one of the projects of Diletta Paghi, who is a PhD in our group, she was dealing exactly with the relationship and the composition between Spain and Italy, and why they change, where they taking the materials and the recipes from other places, or where they developing the technology by the steps. So yes, for sure there are many studies about it.
Yeah, and an exchange also of knowledge and technologies, and probably tailored to whatever resources would have been available locally.
Exactly. Yeah, exactly. For example, also the lead which was used, we are able to trace it by lead isotope analysis, and the results were quite interesting.
Interesting. I know we're at time, but we have one more question. So from Greta, wonderful presentation. Oh, we have two more questions. Let's see. Wonderful presentation. I got a bit lost when chromium was briefly discussed for porcelain. Could you clarify if you found that chromium was or was not commonly used in porcelain before the 19th century?
No. So before the 19th century, no. It was first used, if I'm not wrong, at ACerS in 1902, if I'm not wrong. Sorry, not 1802, sorry. And then at the Genori manufactory as well, and at Meissen, but it was introduced in the 19th century. Sorry if I was a bit confused.
Okay, thank you for clarifying.
What I was saying, it was just that they had it at the Genori manufactory, but they were not using it for Maiolica.
Gotcha. Okay, and then there's a thank you from Agathi, and then Kadane says, many thanks for the nice and informative presentation. I have some questions if we have time. Let's see what we can get answered. Were there attempts to optimize the XRF measurements for the light and heavy elements? So were they optimized differently? Let's start with that question.
In this case, not, because we had like an ARTAX spectrometer. We cannot play a lot around with the conditions. So what I did not mention is that we cannot see sodium, for example, in the composition, but we can see all the other elements. We were using helium in a few cases, especially to detect the silver in the luster, but otherwise it was not necessary.
Then I saw arsenic assigned in some of the spectra displayed. How did you handle the spectral interference with lead, for example?
It's a good question. So it depends. With the arsenic specifically, we did not detect it often. It is mainly present, of course, because in glazes we don't have arsenic pigments because it is too volatile. Arsenic is present often in cobalt blue as an impurity. In a few cases we could see it, but let's say I decided that it was present only if I could see the K beta line in addition to the K alpha. So. Of course, otherwise the lead is so high that you cannot see anything.
Yeah. And then this is an interesting question. Why molecular techniques like Raman spectroscopy were not considered?
This is a very good question, mainly for logistics logistic reasons, we did not have the technique available or either time to use it. But yeah, of course, this is also a very good technique, especially to study the antimonete for the yellow, for example. But in other cases, it's also more difficult, the interpretation, when you don't have, say, mineral particles to identify. But yeah, for sure, it is also a technique which is widely used in glaze studies.
I will say, when I've tried to use Raman before on ceramic glazes, it can actually be quite difficult, especially considering the penetration depth of Raman. If you have a glaze that is like an amorphous silica glass and the pigment is below, like the sampling depth is only about a micron or so. So if the pigment isn't right in that level, it can be very difficult to pick up the signal from the colorant.
It is. Yes, I agree. I definitely agree. I'm sure there are many studies, so it's possible to be done. But we tried, for example, with the dark red. The picture I show are from a Raman microscope, but we were not able to acquire any spectrum. And also there is a high fluorescence and reflectance.
Yeah, no, that makes total sense. And then the last question, and then you're free to go. You did not carry out hyperspectral analysis on those from the V&A collection? It's a question. Did you carry out those?
Yeah. No, we did not. This is a very recent, a more recent project. But yeah, we could do. The camera is actually of the University of Bordeaux, with the colleague of the colleagues of the University of Bordeaux. So we did not do it.
Okay. Well, those are all the questions that we have right now. Thank you so much for the presentation and for taking the time to come here. It was such an honor to have you here. And thank you to our audience for tuning in. And we'll be back next month. So stay tuned for that announcement and have a great day. Bye, everyone.
Thank you. Bye-bye.
Bye.